Welcome back, STEM chemistry students. This is Ms. Ruark. We're in vodcast 3.1, which is in the unit with moles, and this is fun. So let's get started. All right, so here's a question I want to pose to you. If you had a mole of dollars, how long would it take for you to spin a mole of dollars or dollar coins if they were being spent at a rate of $1 billion per second? All right, so think about that. You're like, I don't even know because I don't know what a mole is. Okay, well, let's figure that out. All right, in chemistry, we always have to measure the amount of stuff. So how are different ways that you can measure the amount of stuff? So let's say that you were looking at a sandbox and you needed to measure the amount of sand in a child's sandbox. Well, you could count each grain of sand and that would tell us the number of particles. I don't know about you, but I don't want to do that. That doesn't sound like fun. You could weigh the sand, which would tell us the mass of the sand. That would give us some information. You could measure how many bucketfuls of sand there are, which would tell you how much volume you have. Or you could do what chemists do, and you could use moles. And we use moles to convert the number of particles to mass or to the volume and vice versa. All right, so in chemistry, chemical reactions and chemical equations are kind of like cooking. Except in chemistry, we don't lick the spoon. Probably not advised. Okay, so what is a mole? Well, a mole is equal to 6.022 times 10 to the 23rd particles. Now, particles is not the unit. Particles is just a word that fills in there. So if we're talking about a mole of Diet Cokes, we'd have 6.022 times 10 to the 23rd Diet Cokes. If we're talking about molecules, then molecule goes in place of this word. If we're talking about donuts, then donuts goes here. All right, well, what is a particle? Well, elements have particles. Those are what we call atoms. And if we're talking about a compound, if it's a molecular compound, covalent, then we would call it a molecule. And if it's an ionic compound, we call them formula units. All right, so we distinguish between what we have there. Ooh, it just kept going. All right, so why is this important? Well, because we use moles like we do use measuring cups when you bake. All right, so how does that work? Well, let's go back to Molinaire. How long would it take for you to spend a mole of $1 coins if they were being spent at a rate of $1 billion per second? All right, well, we start with what we know. We know that we have 6.022 times 10 to the 23rd dollars. Right, that's 1 mole of dollars. We're going to be spending these at an alarming rate of $1 billion, which is 1 times 10 to the 9th per second. Huh, that's a lot of money, y'all. All right. But if we do that, it's going to give, when you put it into the calculator, it gives us this number. Now, I don't know about you guys, but this number right here, that many seconds, I can't wrap my head around that. So let's change it from seconds to hours. So we'll multiply it by a fraction. Second goes on the bottom and hour goes on top. In 1 hour, there are 3,600 seconds. So now we do the math, and the calculator is going to give us this number, 1.673 times 10 to the 11th hours. Okay, that's still too big of a number. I can't wrap my head around that one. So let's change it from hours into days. Well, in 1 day, there are 24 hours. All right, well, the calculator is going to give us 6.97 times 10 to the 9th days. Y'all, that's still not making any sense to me. So let's go from days into years. So how many days are in a year? 365. Don't get accurate. 365.25. That's fine if you want to do that, but we're just going to use the rounded number. Days cancel, and it leaves us with 1.91 times 10 to the 7th years. Okay, I don't know about y'all, but that's still a huge number. But I don't want to go down to decades or anything else like that, because then we're just getting crazy. So let's just talk about this in years. This is the same thing as 19 million years. So it would take you 19 million years to spend a mole of dollars if you spin it by, if you spent a $1 billion a second. That is a long time. That's a big number. All right, so how do we use moles? Well, we use moles to compare things. We use moles to talk about the quantities that we use to react in an equation and how much we make. Okay, so let's compare sugar and water to see how moles are related to amounts. Well, if we had one gram of each, 1 gram of sugar and 1 gram of water, would it be the same volume? No, because they have different densities. Well, would it be the same mass? Yes, because it's 1 gram of each. What about the same number of moles? No, because we have different molar masses. Number of molecules? No, because it's different molar masses. What about the number of atoms? No, because there's a 45 to 3 ratio. 45 to 3, that's a big number. 45 to 3 ratio, right? 45 to 3. Holy cow. All right, what about moles? If we had this 1 mole of each, would it be the same volume? No, because the molecules are different sizes, they'll occupy different amounts of space. What about mass? Would they have the same mass? No, because they have different masses. What about the number of moles? Yes, because there's 1 mole in each of them, so we could count them. It would make it a lot easier to count them that way. What about molecules? Yes, because we have 6.022 times 10 to the 23rd molecules in each one. And then the number of atoms? No, again, because we don't have the right ratio. Just to compare and let you see how they're related to amount. All right, so how do we use moles? Well, we've got to throw in that dimensional analysis. So first thing you need to do is read your problem. How many moles of magnesium is 1.25 times 10 to the 23rd atoms of magnesium? So what are we looking for? How many moles? So let's circle that. What do we know? We have 1.25 times 10 to the 23rd atoms of magnesium. All right, so 1.25 times 10 to the 23rd atoms of magnesium. That's what we know. So I always start off with what I know. And I set it up, this is what I know is equal to this is what I want to know. All right, now you're probably going, Miss Rook, you left your E off here. Yeah, I didn't tell you that, but the abbreviation for mole, you just take off the E. I know, crazy. That's all right. You'll get used to it. Okay, so how do we solve this? Well, we say that 1.25 times 10 to the 23rd, that's what we're starting with. And we know that we have a conversion factor that says that 1 mole of anything is equal to 6.022 times 10 to the 23rd of that thing. So we're going to multiply this by a fraction. And we're going to say if we have atoms here, well, we need atoms on the bottom. And we want to know moles, so moles goes on top. Looks like a heart rate, right? Okay, what numbers go here? Well, 1 mole, 1 always goes with mole in this fraction, and this one is 6.022 times 10 to the 23rd. All right, atoms of magnesium cancel. We're left with moles of magnesium. And now we do the math. So how do you do the math? Well, 1.25 times 10 to the 23rd. And if you're not sure how to put this into the calculator, make sure you bring it to me so that I can help you. Okay, 1.25, 23, divided by 6.022 to the 23rd, and you should have gotten 0.20757, oops, wrong one, 2235. That was supposed to be a 7 right there, right? Okay, how many significant figures do we need? Well, we come to the original number in the problem. We have 3 significant figures there, so we need 3 significant figures here. So 0.20, the 5 makes the 7 go up, moles of magnesium. And that, ladies and gentlemen, is how you use moles. All right, so here's some practice problems for you. I am going on the assumption that you are extremely bright young women and men, and you know how to do this. So I want you to try these on your own. And then when you come to class, we're going to check every single one of those tomorrow. Okay, let's move on to molar mass. So what is molar mass? Well, molar mass is the mass of 1 mole. We call it the molar mass. So 1 mole of lithium is equal to 6.94 grams of lithium. And we express this as moles per gram. Oops, sorry, I did that wrong. Grams per mole. Molar mass, grams per mole. How many grams per 1 mole? All right, so you will need your periodic table. If you don't have one, get one. All right, so sulfur. On the periodic table, it says 32.07 grams. Well, guess what? 32.07 grams is your molar mass. That's 32.07 grams per mole. That was easy. I know. Look at the difference between the units. Grams, atomic mass. Grams per mole, molar mass. All right, what is SO2? Well, we've got to break this down into the elements that make it up. So we've got sulfur and we've got oxygen. There's 1 sulfur and 2 oxygens. The mass of 1 sulfur is 32.07 and the mass of oxygen is 16.00. All right, let's go on ahead and keep doing this math. 1 times 32.07 is 32.07, and 2 times 16 is 32.00. All right, but we need the whole thing. So we're not going to leave it just like that. We're going to add it all together. You guys might have done something like this already before. All right, so 32.07, that would be 4, that would be 6. So 64.07 grams per mole of SO2. And that's how you do that. Okay, so you know how to do this one now. I want you to do that one on your own. Come check your answer when you get to school tomorrow. All right, calculate molar masses to 2 decimal places. So you've got lots of practice here. All you need to do is the evens. If you want to do all 5 of them, go for it, but you need to do the evens and bring them with you to class tomorrow. All right, molar mass. Don't be fooled by other names. So gram atomic mass is the molar mass of an element. Okay, so if we're talking about just an element, we would say gram atomic mass. Gram molecular mass would be the molar mass of a molecule, which is in a compound that is covalently bonded. And gram formula mass is the mass of a formula unit, which is the same thing as an ionic compound. Okay, they all mean the same thing. The only difference is atomic mass, element, molar mass, molecular mass is for covalent, and then formula mass is for formula unit or ionic. Just know the difference, that's all. Okay, how do we convert between grams and moles? Well, if we're given the number of grams of a compound, we can determine the number of moles and vice versa. So if we're given the number of moles, we can find the grams. In order to convert from one to the other, you first have to have the molar mass, and you would use that to convert. So how do we do that? Well, in question number 1, how many moles, that's what we're looking for, how many moles are represented by 16.0 grams of ethanol? How sweet, that gave us the chemical formula. So we want to go from 16.0 grams of ethanol, C2H5OH, and we want to know how many moles. Well, in order to go from grams to moles or moles to grams, we have to have the molar mass. So we break it down, C's, H's, and O's. We have 2 C's, we have a total of 6 H's, and we have 1 O. Each carbon has a mass of 12.0, each hydrogen has a mass of 1.01, and each oxygen has a mass of 16.00. So we have, oh, your periodic table says 12.01, don't want to mess anybody up. All right, so we just do the math. 24.02, 6.06, and 16.00. Add them up together. We got 80 point. That is 4, 16. Carry the 1, 2, 3, 4. 46.08 grams per mole. Hopefully somebody's checking my math and not taking my word on this. Okay, so we start off with the number that they give us in the problem. All right. And we multiply that by a fraction. We want to get rid of grams, so grams goes in the bottom, C2H5OH. What are we looking for? We're looking for moles, so moles goes on top. All right, well, 1 mole is equal to how many grams? 46.08, that's why we just did that math. All right, in this fraction, grams per mole, moles always has 1. Grams will cancel. And now all we have to do is do the math. So we do 16.0 divided by 46.08, and the calculator says 0.34722 repeating. Well, we need 3 significant figures, so we need to go to 3 significant figures, 0.347 moles of C2H5OH. And make sure that you circle it, highlight it, box it in, something so that I can see it. All right, so you're going to try number 2 on your own, and number 3 and number 4, and number 5 and number 6. I know you have homework. Oh my gosh. Make sure you have all of those problems done before you come to class. I don't care if they're right or wrong. I want to see that you actually tried it. We're going to check those. Those will be your grade. Not the notes, the problems. All right? I will see you in class, ladies and gentlemen.